All right. So I think I already showed you this in Excel, but I've got kind of a slide here that kind of summarizes. So we've talked about measures of central tendency. We've talked about measures of dispersion. So we've got our mean, which Excel calls the average, median, mode, our population and sample variance, which is just var.p and var.s, and then our standard deviation for our population, stdev.p, and then for our sample standard deviation, stdev.s. Basically, we just use all these functions. So let's say I had this kind of grade data, or I've got all these scores, right? If I want if this is a sample, I can treat this as a sample variance, just select the entire range of data. So that was where we go to the first cell, Control Shift, Command Shift on a Mac, hold that, hit the down arrow, it'll select the entire column. We hit Enter, it'll put that end parentheses on there for us and kind of exit out of that cell, right? We would do the same thing for all those other functions. You're just selecting the variable that you want to find the average or the mean of, the median of, the mode of, right? I could do the mode here. So the mode will tell me, oops, the most common grade in this class is 75, so on and so forth. Like I said, I can't remember if we went over it. I've got 3 different sections. We're all at different points, so because I meet on different times. So nothing too terribly tough there. We kind of went over the variance last class. So what I'll start out with here is, oh, actually, if I remember to pull this up. I had it open earlier. So we are 221. I'll start this up here. Taking a second, there we go. All right, so there was a video that you were supposed to watch before class. This will be kind of first look at how we'll use these. Literally all I want to know, all right, so I've got the eye clickers open. What kind of topic was that video covering? All right. Might have even been able to just read the description instead of watching the video. You should be able to get this one right. Okay. So the pre-class video that you expected to watch before we started today, what was it covering? So a couple of you just got here, so I'll let you kind of set up. Well, hopefully next 10, 15 seconds, you can get everybody with an answer. Okay. If you haven't gotten an answer in, make sure you, I guess, take your best guess now. I'm going to close it out. So we got 30 of us here today. All right. 31. So if you're paying a little bit of attention to that video, kind of the setup that I had, and I kind of reiterated here, was that we had kind of this grouped data, right? And we had GPA measures of 3 different groups, sophomores, juniors, and seniors. I'll kind of put the numbers back up here. We had 10 sophomores, 40 juniors, 50 seniors. So when we were looking at the group's GPAs, which one would have impacted that weighted mean, which is what should have been the last answer, right? The video was covering weighted means. So if I'm calculating the weighted mean, which one of these 3 groups would influence that mean the least, right? So given that there's 10 sophomores, 40 juniors, 50 seniors, we just saw the GPA of each one of those groups. Which one of those would influence the weighted mean the least? I think we had 31. Maybe I was picking up someone from different class. So make sure, take your best guess here. I'm going to close it out right at this minute mark. Everyone's good? All right. 32, we're good? All right, closing it out. All right, so what should the answer to this be? Yeah, right. We're thinking about what group influences it the least. It's just going to be the group average that represents the smallest number of people, right? And I kind of walked through that video and showed you if we have the number of individuals in each group, essentially we're going to start weighting, right, that GPA measure by however many people are in that group. So this should be, I mean, I don't think these are tough questions, right? Hopefully, I mean, these are, as long as you kind of hold the video open and like half listen to it, I think you probably could have gotten these correct. But, right, it kind of primes us so I don't have to kind of start out necessarily with an introductory example of weighted means. Like I said, that's under the assumption I'm expecting that you've watched it. Okay? So weighted means we're going to use when we've got group data, right? So anytime, you know, it'd be ideal if I could have seen every single student's GPA, but I couldn't. I could only see it based off of their class level, right? Sophomore, junior, senior. So anytime I have group data, right, I might want to treat those groups not equally because they may represent a different number of individuals. So I think I did this with the variance already, right? But we said if we're thinking about the mean, another way that we could write that mean is just each observation is really just being weighted by one out of however many observations are. Right? So this was just kind of writing out, it's just adding up all the x's, but each x is divided by n. That's the same thing as multiplying each x by 1 over n. Right? So with a regular mean, we're weighting every observation equally because it represented one individual, right? One company, one whatever. Here, when we look at the data, if it's grouped, right? If we have group data, some categories are going to carry more weight. And don't worry about this example. I don't like it. I used a different one in that video, so that's why. So my weighted mean equation is going to look something like this. I'm going to go through every single observation I have, or like every single group that I see. I'm going to take the value for the x variable I'm interested in for that group, multiply by whatever the weight I'm using. These weights are more often than not going to be some type of like a frequency or a count of the number of individuals that are represented by that group's average. I'm then going to do that for every single observation, add them all up, and then divide by the sum of my weights. Right? We'll get into that a little bit more here in a second. So I have to write out these steps kind of in words. I'm going to go through every observation, multiply its value by its weight, do that for every observation, add all those products up, then add up all the weights, right? Divide the sum of the products by the sum of my weights, and that gives me my weight. There's a couple other ways of thinking of this here in just a second. So let's say we have an example like this. Actually, before we get to that, I'll break it out a little bit more. I think I might have done this a little bit more. So let's say I had that example. I don't remember the exact numbers, but it's not that big a deal. 3.0, 2.5. Another way I can think about this is, so here was my variable x I was interested in, which was GPA. And essentially here was going to be our weights, right? The number of individuals in each group. So this, I think, was sophomores, juniors. I can go through this process, multiply the x value for the first group by its weight, write that number down, multiply the second group by its weight, write that number down, so on and so forth. So if I do that, right, there's my numerator. What's in my denominator is the sum of my weights. Well, the weights I'm using are the number in each category, so I could just 10 plus 50 plus 40. But we notice another way to think about this. So this is probably procedurally the easiest way to do it. But another way of thinking about the weighted mean is that you could also use proportions, right? And this will make sense kind of for future subjects we're going to talk about. But how many total students do these three groups represent? 100. Yeah, 100, right? 10 plus 50 plus 40, this is 100, right? So one thing that's kind of interesting here is the sum of my weights is actually whatever the number of observation was in that data set before it was grouped, right? There were 100 individual GPAs or in some data set that I can't see. It was then grouped into these three groups and presented to me that way. But when I'm adding up those weights, well, that should just be every single observation. So we really still have like n in the denominator. Right? It's kind of a not like the mean, right? But we originally had, it's just to get that sample size, we have to add our weights up because we can't see that original data before it was grouped. So another way to think about this is, well, this group 1, right, is 10 out of the 100 observations. So I could use that 10 out of 100 as my weight, multiply that GPA of 3.0. And then just like we would with a regular mean, it's just I'm not weighting everything the same now. Now it's whatever proportion of the total observations that group makes up. So the second group would be 50 out of 100. Multiply that GPA 2.5 by that proportion. The final group is what? 40 out of 100. We'll multiply their GPA there. This will actually give you the exact same answer as this up here. It's just a different way of thinking about the data. So whichever way is going to be easiest for you to think about. Now, this way, it's a lot more complicated when I don't have a nice denominator of like 100, right? It's harder for me to think about, and the values are a little bit more difficult to work with if I have like, you know, I don't know, 13 out of 142 or something like that. So another thing I want to point out here is, even if we think about this in the same way, where we're using this formula, and let's assume that these proportions that we've created, that these are our weights, right? What would the sum of our weights be here? So I'd have 10 over 100 plus 50 over 100 plus 40 over 100. What would that denominator actually be? Yeah, right. I just got the sum of my weights over the sum of my weights. So it's just 1. So if we want to like use proportions as weights, right, where we know those proportions have to add up to 1 because we've got every single possible observation, it's almost like we can really just ignore that denominator because we always know if we're using proportions as weights, right, that this will always be, the denominator would always be 1. Any questions over any of this so far? Yeah, we'll get a few more examples here. So here's that data where if you want to, you can go out and grab income data from the census, but they won't give you the original data. Like they have in a database in like each individual's income. I mean, I don't think you can't see their name or anything. It's just like some ID number. But when you want to download it, right, they will only give it to you in groups. Okay? So here I could download average income values from this sample that the census has, but I can only do it by race and gender. There's some other characteristics that we'll kind of look at that you can break it down by as well, but this is one of them. So this might give us a look at, you know, racial or gender equality across it. So I've got each one of these mean incomes represents a different group. But we know the demographics of the US, not every one of these racial groups is going to be represented equally, right? There's different percentages. So we look here in the sample, right? The most common race that we had was white, followed by Hispanic. Now, obviously, the census is breaking this down to 4 categories. We could blow this out to many more, but for how they present it, this is what we have. So this mean income value is representing a higher number of individuals in the US than, say, this income value. Right? 73 versus 6,000. So the categories that have the highest number of individuals in it, they should be influencing that weighted mean a little bit more. If we want to calculate the overall, say, average male income here, we're going to have to create a weighted mean. We've got 4 different groups, X values, and each one of those groups weights. They said usually our weights are going to have to be frequencies, the number of individuals in the group, the number of companies, and that this represents. So here, how would I go through and do this? Well, if it was me, right? We'll kind of come back to the female data in a second. I would like put a column right next to this table and just 4,000 almost, multiply by 59,000, write that number down. 11,000 times 38,000, write that number down. Do that for each one of these race categories. We then have 4 products. Add those all up, and then divide by what we're using as our weight. That was the number in each group. So the sum of our weights, which I kind of actually already put up here, which is kind of nice, right? If you do that ahead of time, there's not as much going on in that weighted mean equation, right? So I would always kind of break this up into the numerator and denominator, calculate each one of those individually. Then you just have one number to divide by another number, as opposed to entering it all in your calculator at once, which looks something like this, right? It's a little bit easier to make mistakes there than, but actually was putting this in my calculator, what would have happened when I'm doing? I have to make sure that there's parentheses around all this. Any questions on just the process or the idea? So we can kind of see, right? I mean, if I were to treat this as, I had a calculator on it. If I were to treat this as a regular mean, and I just added these values up and divided by 4, I'm looking at this. 40. You would definitely have a value below 50,000. I don't know what this is. If I add 59 plus 38 plus 60 plus 36,000 divided by 4, I might end up with something that's just below 50,000. If I treat it as though it's a regular mean, but it's group data, and that 59,000 represents way more people, a way larger slice of the pie, right? 73,000, almost probably about 70% of the people in this sample belong to that white category, right? While only like 11,000 people are represented by that 38. So that 38,000 is going to have way less of an impact on that weighted mean than the 59,000 value would, right? Because it's representing a high number of people. And if I was actually able to see the individual level data, right, there would be way more individuals, 73,000 that have incomes that are, right, at least somewhere around that measure of central tendency of 59,000 for that group, as opposed to only 11,000 people around that 38. So whatever group we have the highest weight for, that's the one that's going to influence the mean the most. So notice, if we don't treat it like it's a regular mean, where we get just something under 50,000, but we use the weighted mean approach because we have group data, that average actually ends up being a little bit closer to that 59,000. Right? That 59,000 influenced a little bit more, and the weighted mean is 53,000, whatever it is. Okay. Questions on that? All right. You can do the same thing and come up with the weighted mean for female income. So I put that value here. If you're looking at the slides, you can kind of see I just put some white boxes over it. You can move those, and if you wanted to, it might be a good thing on your own if you're having some difficulty with these weighted mean examples. Go try to like reproduce that, right? Try to come up with that answer by using the female weights and the female incomes. What if I'm looking at something like this? Right? Hopefully, we've had a couple discussions now, so hopefully these should be easy points, but let's see how close we're following things. So if I open this up as an IQ question, I think I have. Let's see if I did this in the right order. Maybe I'll show you. There we go. All right. Which one, doesn't matter if we're calculating the weighted mean for females or for males, which one of these regions, right, would influence the weighted mean the most, right? So A, B, C, or D, which, kind of lined up right next to them. Which of these regions is going to influence that weighted mean the most? Probably 15, 20 seconds here. It shouldn't be too tough. Gives me an opportunity to get it. All right. Everybody got an answer in? I think there was 32 of us earlier too. All right, I'm going to close it out. This one should be fairly easy, right? Which one of these regions is going to have the largest influence? Yeah, right, the South. Why? I mean, it's significantly larger than the other 3 regions, right? It's representing a significantly larger number of individuals. Right? So here was another example. So instead of gender and race, I broke it down here by gender and region of the country. I think you can do some stuff with like ages as well. I forget all the different categories the census has. But the same kind of thing's going to apply. We could reproduce these values the exact same way. Just go through, take each group's value for X, which is income, multiply it by the weight of that group, do that for every single one of these regions, add them all up, and then divide by some of my weights here, which would just be adding up the number of people in each region. Okay. What if I wanted to calculate the overall weighted mean income regardless of gender? So for the entire country, I want to find the weighted mean income. What would I, how would the process of what I'm doing change, or what would look a little bit different?
Did you say regardless of the?
Yeah, so I don't care. I don't want the male weighted mean. I want just the weighted mean income across.
Will you just add them?
Yeah, I go through the same process. So I take each region it's basically like, I can just pull this data and put it right below here. And now I've just got 8 different categories, right? I've got 8 different groups, right? Of those 8 groups, notice the largest is actually kind of my South females, right? That would have kind of the highest influence. But it's just more moving components, right? I still go through, and each group's mean, I would multiply it by its weight, add them all up, and now the sum of my weights, I just have 8 different weights to add up, as opposed to 4. The process will still be the same, just a little bit more work there. This is always sad. I mean, I don't know, sad. It's tough to look at this data when you're like, you just realize like the racial and gender disparities in income, and you're like, how do we solve this? But it is what it is, right? So this is the data, is what it is. We can't do anything in the moment to change it, but we can analyze it, and we can use it to show like what those disparities are. Okay. So that's the weighted mean. I don't think it's like it's not the hardest concept. I think sometimes the difficult part of it is identifying when you need to use it. And anytime you have something representing a different number of individuals, that's a really good example. I know those are really good examples where we can see that. The other one is, I'll show you an example of this. And it might kind of ring, or it might remind you of, I don't know, things maybe in some other classes. So let's say I had instead, I'm thinking about like a portfolio, a stock portfolio or something, and I've got one stock or one mutual fund, whatever this is, that I've invested in. Its return was 4.2 thousand. And I invested 500,000 into that stock or mutual fund or whatever kind of asset. I then have another one that, I don't know, had a really, really good return. I had 100,000 invested in that. And I don't know, let's do one really bad one. Right? And then do something like, oh, I don't know. I knew this was risky ahead of time, so I only invested 50,000. Well, if I'm looking at this portfolio, I wouldn't just say, oh yeah, its average rate of return is, I don't know, add these up and divide by 3, right? Which I'm going to end up with a negative value there actually. I have something like 11 plus 4 is 15 minus 20, so negative 5 divided by 3, right? So maybe just under like negative 2% there. Well, if I look at this portfolio, I'm like, well, yeah, there was one stock or one mutual fund that returned or really like had a huge negative return, but I didn't have hardly any money invested in that relative to this one that did kind of just okay. Right? So here's a good example where I don't have like a frequency or a number of individuals in the group, but I still have something that I should be using as a weight, right? Because of the overall pie, right, of the total dollars invested, right, more of those dollars were in this stock than in this one. So I would basically do the exact same process. It's just now I'm using that amount invested as my weight. On negative 20.1. And then my denominator here, instead of representing like n, or the number of individuals in the original data set, really what here the sum of my weights is going to represent is like the total dollars in my portfolio, right? So I just add my weights up here. And it's the exact same process as what we were doing before. It's going to look a little bit different. Like I said, most often I'm going to probably use examples where that weight is some number of individuals or some number of countries or something. But there are other types of examples where if we're thinking about we have this return and the amount invested in each one of these stocks is different, This is another great, situation where I should be using the weighted mean. Right? Anytime I have something, I can use my weights. Any questions on this? Yeah.
So that's like, I think you alluded to this earlier, but so that, how you wrote that there, you'll get the same answer as taking like, okay, 500 grand is X percent of total 650, then times you for multiplying that by 4.2.
Yep. So I could ahead of time have created my proportions. So I've got what, a total of $650,000 invested. I could have done what, 500,000 over 650, so on and so forth. And then I would have just used these as my weights and essentially had no denominator, or at least there was a denominator, but I don't have to worry about it because I know it's always going to be equal to 1. Other questions? And this, I guess, from the highlights, I'm doing a little more work on the board today. So this is like another added benefit of showing up. Like, even if you want to watch these recordings, like they're not always going to, have what I'm doing up here on the board. Although if you ever get like I don't care. If I ever get like an exit interview and they ask you what something they could do in the College of Business that would be helpful or to improve it, I used to say that they should make everything whiteboards. They've done that now. I like to think maybe I had some small hand in that, like mentioning to every section. But the second thing, I now want, I'll go off on a rant here in a second. The third thing I want, we'll talk about the second thing in a second. The third thing is if they just put cameras up here and every room has a projector, it's pretty easy to just put a camera off to the side of it so you can capture the entire front of the room. I don't understand why they don't do that. That has to be like such a low cost relative to some of the other things that they purchase. So if you ever ask about anything, the exit interview or anything that could be better, put that down for me and I would appreciate that. You guys would probably appreciate it as well. You get a much better video, you have more resources if people want to use them. Especially in light of the pandemic, I don't understand why we didn't do that, but I don't know. People get paid more than I do to make these decisions, right? So the third thing, I'm just wasting time right now, but that's fine. We're ahead of the other section. So move the damn clocks to the back of the room because I can never tell what time it is unless I like awkwardly look all the way across the screen. So these are all my gripes today that I'm getting out. I guess I'm like cranky today. So we'll start this next topic. We'll get a little bit ahead of where the other section's at, which I think will be good. It's a little bit more time to go through some of the next material with probabilities slowly, because the next topic of probabilities that we'll get to, I don't know if next Wednesday, but definitely next Friday, it's definitely going to be a little more difficult. So the weighted variance is going to be really similar to what we were doing with the weighted mean, right? So if when I'm looking at the deviations from that middle point, if I only have group data, I don't know what this value ends up being, but we had the 53,000 earlier for the average male income. Well, now we have to look at how much does each group vary from that middle point. However, thinking about the variance as the average measure of kind of dispersion, or the average measure of how far away observations are from the mean. Well, now each group is going to represent a different number of people. So instead of them influencing that variance the exact same amount, each group should influence the variance by whatever proportion of the overall data they are, right? So we're going to have a formula that looks very similar to what we were doing with the variance before, but now notice every deviation squared, well, that's for group data. And so each one of those deviations from the mean is going to be representing a different number of individuals or a different amount invested, right? And so I'm going to have to multiply that deviation by its weight, right? That category, or that group's weight. And then on the denominator here, I have written as like n, the number of observations, but it's the same idea as we had over here, right? The way that I'm going to get that, unless I'm told, well, here was the number of original observations in the data before it was grouped, I'm going to have to look at the weights, come up with that total number of observations by adding up all the weights. Okay. So here, rewrite that and some of the weights are. Either way, I want to think about this. Okay. So we'll go through an example here. I've already had it worked through, but I'll kind of show you how you walk through it, right? So I've got that. I can't grab just the male income data. We'll broken down my race, right? So this group's deviation from that mean of 53,000 should be weighted more because that represents a higher number of individuals. So what I would go through and do is take that 59,000, subtract the mean of 53,000, square that value, and then multiply it by the weight of 73,000. Write that number down. Go to the next group. 38,000 is deviation from the mean. So 38,000 minus 53,000. Square that value. Multiply by its weight of 11,800. Write that number down. Do that for each of the 4 groups. Add up those, sum of the weights times the deviation squared. Once I add those up, divide by the sum of my weights. That should give you that 94,000. You kind of see here, I won't give you examples like this in the exam or anything like that. I mean, when we deal with income, someone asked me, the variance is kind of hard conceptually to think about until we start using the standard deviation for other things. But you can kind of see the variance is influenced by whatever the original variable is. So here with income, because we typically see pretty large values, right, we're going to be able to see deviations of like 3, 4, 5,000. So when I start squaring things and multiplying it by the weight, notice we get some really large values. Now, if I'm dealing with a variable like height that's measured in inches, I can't ever see a deviation from the mean of 30,000 or 3,000 or even 300, right? So the size of the variance is kind of dictated by whatever the size, the units or the range of the data that you're originally looking at to begin with. So really, we can only use the variance to compare across data that has a similar unit. So I could compare across countries, maybe the weighted variance in income, right? But I couldn't compare the variance in income to the variance in height. Yeah.
So you subtract the mean from sorry.
Yep. So it's just like we were doing before the variance. We're going to take that deviation from the mean squared. So I'll take 59,000, subtract 53,000. That was the mean that we had. Oh, right there. All right. Going back, we did the weighted mean earlier. So we'll use that weighted mean, find that group, 59,000 minus 53,000, square that deviation from the mean. And that's what we were doing before the variance. The added step now is I take that deviation squared and I multiply it by the weight that I have for that group, which would be the 73,000 in this case. Any other questions or clarifications? Yeah.
So once you get those numbers on the right,
Yep.
what do?
Right, so remember, when we have these deviations squared, multiplied by the weights for each observation, we then add them all up. Like that summation sign says, once you do that for each observation, add these all up, right? It's gonna be a really large number, and then you divide by some of these weights over. I think I might have, let me see, I think we might not. I'll do it for kind of the female one here, since we've got probably plenty of time, yeah. I'll write this out so you're a little bit better on my computer. Not the same words here. So let's say we want to find the weighted variance for female income. Now that I said that, I forgot what their average was, and that's going to be important, right? Can't find the deviation from the mean if I don't know the mean. So female income, what we had here was 22,000 from this data. This data was a little bit older. So 22,000. I'll just use that, kind of round that to make it a little easier. So we've got each group, right? We'll find their deviation from 22,000, right? That was the weighted mean for female income. So the first group we've got what? And I'll probably, you want to, low cost. Right? So I take that group's value, 34,428. I'll subtract that mean. Right, this was kind of representing our mean of 22,000. That's the deviation of that group from the mean squared. But I then need to multiply it by, well, how many people does that group represent? 75,502. Add to that, what's the next group's income? So 28,428. Minus that mean of 22,000 squared. That group is only representing what? 14,569 people. So I multiply that deviation squared by how many people were in that race category. Then I'll go to the next one. what, 39,458 minus that mean of 22,000. Take that deviation, square it, multiply that deviation squared by however many people are in that group, which is what, 6,150. One group left, right? Their average income was 24,731. We'll subtract that mean of 22,000, square it, multiply it by however many people are in that group, which is what, 14,691. Now, if you're taking notes, probably is a little bit easier to see this all in one line, but I don't have the room to do that without going real small so you can see it.
So that 22,000, is that a weighted mean or is that? just
Yeah,
a regular
so
mean?
if we're gonna have group data, by the time we get to calculate the variance, I mean, to calculate the mean, we had to do a weighted mean, right? So anytime you're doing a weighted variance, you have to use a weighted mean, right? Otherwise, you can see the individual level data, why the hell aren't you using it, right? Like, why wouldn't you just calculate a regular mean and the regular variance? Because honestly, this weighted variance is going to capture some of the variance. It's going to do it the best job we can at capturing the variance in the original data. But if I had the original data set with every individual and I calculate the variance, it's going to be a little bit different, right? Because think about it. I've got one value representing 75,000. I don't know how much variation there is from that mean just within that group, right? So I'm doing the best job I can at capturing the variance, but if I have the individual data, that's what I should use. And I still have one more step here, right? This was just my numerator. I would then have to divide that by the sum of my weights. So basically just what? I'm going to shorthand this one. So 75K plus 14K plus 60K plus 14K, right? I'm just rounding those just to kind of shorthand that. You can write those values out if you want, but you really just have to divide by some of your weights here. And like I said, probably in practice, just add those weights up to begin with, like add these four values up and write that number down so that you can just plug that into the denominator once you get there. Any questions on that or anything related to? Yeah.
You said we're gonna do a reference sheet on our exam.
Yeah. So I'll work on getting that here together. So I'll get up on Canvas sometime next week. There'll be a lot of stuff on that you'd be like, what? We haven't talked about this or whatever. But yeah, you'll have the equations in front of you. Now, they're not going to have words associated with them, so they're going to look, like this, right? So you have to know that, like, how to think about how to calculate these things, and how to identify the mathematical notation. But yeah, you can have that. You'll have a formula sheet. Yeah.
For the Excel assignment that's due on the 13th.
Yep.
I thought you might have mentioned something in class, but I didn't see it online. I might be missing it. Do you have an example of like one of the Excels that you did together in class up online?
Yeah, so there should be. Let's go. This is good. So we'll go to not 201. Let's go to 221. Go to files. There's this in-class data folder. So that enrollment's complete is basically all the work that we did in class. And the blank one is where we started, that complete one is kind of where we stopped, right? I also spliced together all the different stuff that we've done in Excel so far, other than like today, me showing you how to do the mean and the variance, although that's, I don't think anything too terribly tough. So if we go here, should be, I want 221 section 3. Nope, I don't want to hear myself talk. So this Excel video number 1 is basically splicing all that work together into one file. So you can go back to that video for some help. You can look at that kind of template, just Excel file. And it's not exactly the same, but it's the same approach you should be taking, right? So it's a different data set and it's maybe a slightly different number of bins or something. But those kind of resources are there for you as well. Any other questions? Do you have a question earlier?
I was just gonna ask about that. Instead of dividing by that sum, what is it that we take the square root of that? I remember going over something in class. Square root.
So if we calculate this entire thing, that's gonna be our weighted variance. The only reason we talked about square roots is if I wanted the weighted standard deviation, right? It's the exact same principle. When I went from the variance to the standard deviation, all I'm doing is taking the square root. So notice the variance is sigma squared. The standard deviation is just sigma. So if I take the square root of the variance, that cancels and I'm just left with the standard deviation. So I do the same thing with a weighted variance. If I got the weighted variance and I wanted the weighted standard deviation, I would just take whatever value that equation gives me and take the square root. Yeah. Probably not. Right? I mean, it's important to get this idea of that the standard deviation is just the square root of the variance. But when it comes to like throwing in then the added wrinkle of calculating a weighted mean and a weighted variance, I'll probably just leave it alone at like and just stop at variance. Any other questions? These are good questions. All right. Let me see if I have another example I'd rather go through. We'll save this for kind of next week. Because that's using midpoint. So I guess at this point, I've got two examples here. If you want some additional practice on your own, you can use this data and then try to go through the same exact process and reproduce those values, right? That 919. So you could go through and do the exact same process with the region data and come up with the variance on male income and the variance on female income. But you know, that's just if you want to, if you're having some difficulties or want some additional practice. Any other questions over kind of any of this weighted variance or weighted mean stuff? So I think what we'll do, try to keep us kind of on the same page. We're going to do some basically the same thing. We'll start off Wednesday, right? Because Labor Day is Monday, so we don't have class. So on Wednesday, we'll do some stuff where we have data presented in groups, but not only is it in groups, but we've only got bins, right? So what X values do we use there? For that first connect homework, you should be able to do almost all the questions at this point, other than kind of the stuff that we'll probably cover in class on Wednesday. For that Excel homework, you should have everything you need to complete that, right? So I know it's Labor Day weekend. I'm sure everyone's got fun plans, especially once you get back to kind of working on things next week. Try to knock that Excel out of the way, and then after class on Wednesday, you should be able to answer every single question that we have in that next assignment. So questions next week, reach out. Since it's a shorter week, we won't be here Monday. You know, if you want to meet during anything else, stop at office hours, send me an email, we can set something up. Okay. Other than that, you guys have a good weekend, and I will see you on Wednesday.